Okay, everyone just watched. I'm going to demonstrate how the MDA3 drives large headphones when paired with the PA1. After adding the PA1 to the MDA3, it drives large headphones, almost like a small desktop amplifier. Many customers have asked how it compares with the MR2, so I'll address this. Why can a portable DAC amp under 3000 RMB, when paired with a 1000 RMB portable PA1, drive headphones like the hd600s as if it were a high-end portable player or a high-end mobile desktop amp like the MR2? The most important point is that it contains some core technologies from our desktop amplifiers. It's essentially the experience from our desktop models, downscaled, and this is something we've been observing for years before we felt confident enough to implement it in this design. It allows you to experience a soundstage and dynamics similar to a desktop amp, even when using large headphones. Now, I want to clarify, this isn't about difficult to drive headphones like the hd600 or hd600s, which might not perform as well with this setup. But for large headphones that aren't too hard to drive, this setup works without any significant issues. The key thing we've heard from users is that the MDA3 or MDA3E sounds like a mini desktop amp. This isn't just our opinion. We've heard it from early testers, media, and users. The most prominent feedback is that the dynamic range is very large, almost like a desktop amp with great control. Let's talk about dynamics here. There's often a misconception that dynamic range, as measured by specifications, equals dynamic performance. These are completely different concepts. What we mean by dynamics in sound is the speed of sound changes, the distortion of those changes, and the distortion in amplitude. Let me break that down, it's a bit technical. What we actually measure as dynamic range is a static ratio of the smallest signal to the largest signal, a fixed static value. For example, if I can lift 20 kilograms, my ability is 20 kilograms. That's a static value. But it doesn't matter how long it takes me to lift it. One person might struggle sweating to lift it over an extended period, while another might lift it easily. Both can lift 20 kilograms, but the experience is very different. Real dynamic performance in audio refers to how quickly the signal can change and the quality of that change. For example, if the signal suddenly jumps from 0V to 1V in 1 millisecond, but some devices can't reach 1V fast enough, they might reach only 0.8V in 1.2 milliseconds. This results in distortion, dynamic distortion. This is a major issue. The dynamic signal should be able to rise and fall smoothly in about 20 milliseconds, but if the power supply is too slow, the signal might fail to achieve its full range, resulting in a weak, lifeless sound. Another problem is when the signal is rising and a descending signal comes in at the same time, causing interference. This is a major form of distortion, often seen in speakers or headphones, where the low frequencies become muddled and lack clarity. This is why we focus on dynamic distortion when designing our DAC and headphone amps. It's an important metric that's tough to measure with current instruments. In speakers, there are some parameters that measure dynamic behavior, like the resistance coefficient and the speed of the power tubes. If a power tube can achieve 1V in a few microseconds, it's a good indicator of speed, but the power supply also needs to be ideal. If the power supply isn't well designed, even the best power tube won't perform optimally. So, a good DAC and headphone amp require a solid power supply, high quality digital output, and strong internal components, all of which contribute to superior dynamic performance. When a DAC headphone amp handles dynamics well, it creates a large soundstage with strong control and impressive dynamic analysis. Dynamic analysis means that even the low frequencies maintain clear layering and resolution. It's not just about loud or booming bass, it's about preserving the detail and texture in the sound. Dynamic performance also influences how much energy you feel. The faster the response, the more powerful the energy you feel through the headphones or speakers. If the membrane of the driver reacts slowly, you lose that energy impact. If it reacts quickly, the energy transfer is strong and satisfying. This is why some systems, like when connecting a DAC or headphone amp to headphones or speakers, feel more energetic and dynamic. They're able to match the original dynamic speed of the source material, delivering an intense energy that mimics a live performance. On the other hand, if the dynamic distortion is severe, you'll feel the energy is weak and lackluster. This is why we focus on dynamic distortion at Soundaware. From the IIS quality to the DA chips 43131 and the 8-channel headphone amp with its power supply, 1380 UF capacitors, everything is designed to minimize dynamic distortion. If we were just concerned with static distortion, we could get by with capacitors of 200 to 300 UF and use a less advanced clock like the A1s. But dynamic distortion would suffer significantly, which is why we prioritize it in the MDA3 design. That's why the Soundaware MDA3 can be considered like a mini desktop amp. Thank you.